Potential and kinetic energy. Those are the two main categories of energy we're going to be talking about. Okay, how is all energy divided? Well, we just said it's divided into two main categories. They are potential and kinetic. And under potential energy, there are three subcategories. One is gravitational potential energy, elastic potential energy, and chemical potential energy. And just like it says, the hints of what kind of potential energy these are right in the names. One is gravitational, one is elastic like a rubber band, and one is chemical. So, what is potential energy? Energy that is stored and waiting to be used. Later is potential energy. Take a look at these pictures. If I were to pull this rubber band with the ball attached, there's a lot of potential for this thing to come slapping down real fast. But unless I let go, it's all potential. There's no kinetic. Remember, kinetic means moving. Same with the safe over here. It's hanging up, but as long as it's just hanging there, it's all potential energy. If I were to cut it, then it would turn into kinetic. But right now, it just has the potential to be kinetic energy. It still isn't. It has the potential. So, what is gravitational potential energy? I bet you it has something to do with gravity. And the fact is, it sure does. Gravitational potential energy has to do with gravity. Potential energy due to an object's position. And the formula for potential energy is mass times gravity times height. Look at the position of this weight. It's positioned way above the Earth. Now it's all potential energy because it has mass, it has a height, and there's gravity involved. Here's another example. Take a look at this big rock from a landslide in California. There's certainly height here. It's got a lot of mass, and there's gravity pulling it down. Again, it's not doing anything at the moment, but it has the potential to become kinetic energy and crush anything that's underneath it. So potential energy equals mass times height times gravity. And there's certainly a lot of it there. How about good old Rover? Rover here has height, he has a mass, and there's gravity as well there too. So Rover also has potential energy. If he should fall to the ground, it turns into kinetic. Okay, well what about elastic potential energy? We did this in class when I blew up the balloon, and everybody in the first few rows moved back as the balloon got bigger and bigger. It never did explode, but it had the potential to explode, and that scared everybody in the front rows of class, and everybody moved back out of the way as I blew the balloon. That is elastic potential energy because that stretching had energy involved, just like a rubber band. Potential energy due to compression or expansion of an elastic object. Look at the ball on the far left. As it comes down, it gets squished right here, and that's potential energy. And then when that potential energy is released again as the ball expands, it turns into kinetic energy. Remember, kinetic energy is moving energy. The boy on the right also has an elastic tied to a ball. And elastics, when you stretch them, have elastic potential energy. Finally, what is chemical potential energy? Well, a piece of coal sitting on the ground has the potential to burn. So there's potential energy involved in that. Potential energy stored within the chemical bonds of an object. Same as electricity. Inside those batteries are chemicals that can be turned into electricity. How about kinetic energy? The whole different category. We know what kinetic energy is. Energy an object has due to its motion. Now remember, kinetic energy has a formula. It's 1/2 mass times velocity squared is what I said. Here it says Ke is equal to 0.5 times the mass times speed squared. Same thing. Now, I also told you in the past that energy cannot be created or destroyed. So, in these pictures that you see, you'll notice that kinetic energy and potential energy, the potential energy happens when the boy is way up here, okay? But on the way down, it turns into kinetic as it's moving. But always the total mechanical energy on the far right is always equal to the sum of Ke plus Pe. So let's summarize. Energy, from a previous lesson we learned, energy is the ability to do work. And we also know there's a secondary definition, which I kind of like too. It's the ability, little dittos, ability to move something. Okay. Now, in our pictures that we saw on the slides, there are different kind of energies. It came down to two basic energies, two categories. One, potential, and the other, kinetic. And we said these energies could be kind of described kind of easily as kinetic motion energy, okay, and potential had to do with different types, elastic, and I'll put these down here. I'm going to do that. Had to do with something called, there are different types, elastic, there was gravitational, and finally the last one was chemical. From my slideshow. Now we're not going to talk too much about chemicals. Let's get it out of the way quickly. In the slideshow you learned that it was anything that stored energy in the bonds between atoms, between the nucleus of atom, between molecules, I should say. So that was like coal was a real good example. Coal had energy stored in it, and when held next to when lit, turned that chemical energy into heat energy. Okay? And this kind of goes to energy can't be created or destroyed, so this potential energy became heat energy, and it wasn't destroyed, it was simply changed from one form to another. Gravitational potential energy had to do with height. Okay, so if an object had height, let's put this guy on a diving board here. He's going to dive off this diving board. If he has height, from there to there, and he has mass, and if there in fact is gravity pulling him all the way down, then before he jumps, he has potential energy. At the height that he's at, he has potential energy. Let's keep talking about gravitational potential energy in particular. Okay, and let's give you some examples. I kind of like the guy on the diving board, so I'm going to stick with that, and let's talk about that a little bit. Let's put that guy back up on the diving board over here. There's our diving board. Let's give him some height, maybe way down to here. And let's pretend down here we have some water as well. All right, and he's going to be jumping into this water. Okay, our height is identified as this part right here. H for height. And let's put some dimensions on this as well so we know our height goes from all the way up over here to all the way down to here. That's our height. And let's say our height is equal to 10 meters. Okay? And let's say we have a boy up here. And here's our boy. He's getting ready to jump. Okay? He has a mass, we'll say. The boy has a mass equal to 100 kilograms. Okay? And we're going to say that gravity which is an acceleration. The acceleration due to gravity, I'm going to give it a nice even number. Instead of the 9.8, which is the real value, meters per second squared, I'm going to round this up to 10 meters per second squared. That's our gravity. Well, in our last slide, we said that the gravity all the way on top, well, first of all, we said that energies cannot be created or destroyed. And I'm going to tell you something else right now. That total energy total E is equal to kinetic energy plus potential energy. Well, up on top, if he hasn't jumped, then the kinetic energy is equal to 0, isn't it? Ke equals 0. But potential energy, before he jumps, is equal to mass times gravity times height. In this case, 100 kilograms times 10 meters per second squared times a height of 10 meters. Well, 10 times 100 is 1,000, and it looks like this is going to be 10,000. Now I could write the units as kilograms, meters per second, meters squared per second squared, which is true. I'll show you over here. Kilograms, meters squared per second squared, but it's too hard to write that. So oftentimes you'll see the shortcut version, 10,000 joules. Okay, so now we know that his total energy on top is equal to potential energy plus kinetic. So on top, I'll put over here on top, our energy, our total E, equals KE plus PE, which is going to be equal to 0 plus 10,000 joules. And I'm going to put a big J for joules. Okay. On the bottom, let's move this down just a bit. On the bottom, right just before he hits, not when he hits, but just before, a sheet of paper thick. That's how high he is above the ground. Just before he hits, the total E there is going to be different. First of all, we know that his height is now 0. And if his height is 0, then on the bottom, our formula still says KE plus PE. But if his height equals 0 on the bottom, then PE also equals 0. But if energy can't be created or destroyed, assuming no friction, no heat loss on the way down, then at this point right here, kinetic energy must be equal to 10,000 joules plus 0 equals a total energy of 10,000 joules. How come 10,000? Because energy can't be created or destroyed. All right, that's great. How about halfway down, though? Halfway down. Well, total E now is going to be equal, he's half the height. So if he's half the height, multiply it out. His mass hasn't changed. PE is still equal to M times G times H. His mass hasn't changed. It's still 100 kilograms. Gravity hasn't changed. It's still 10 meters per second squared. But the height is now only 5 meters. And when you multiply this all out, it's no longer 10,000 joules as it was on top. It's now half of that, or 5,000 joules. Well, halfway down, since energy can't be created or destroyed, we know PE is equal to 5,000. And KE must now equal another 5,000 joules. That's a 5,000 joules. So the total is still 10,000. Okay, so you see how that works? Can you see that halfway down The total is still 10,000. But it's now made up of 5,000 joules for Ke plus 5,000 for Pe. Okay, and it's all because energy can't be created or destroyed. And you could go ahead and figure out what it would be if his height was, 8 meters or 3 meters. And you'd be able to tell me what the kinetic and potential is, because whatever you calculate the potential energy to be based upon his height, you know the difference has got to be the Ke. Hope you got a lot out of this. Hope you enjoyed it. Hope you enjoyed the slideshow. And we'll talk more about this as we did in class. And if you have any questions, jot them down.